Let's talk about asynchronous functions. In Function Handler, when you run a function that takes a long time, even if you're using streaming output to steadily yield it, the function is blocking. That is, that instance of Gramex can't serve any other request, and you'll have to create multiple instances of Gramex to serve other requests. Now, this is fine if you're doing calculations, but if you are, let's say, fetching data from some other server, let's say performing a REST API query or a database query, that's not actually blocking the server, but simply delegating the results and delegating the query and taking the results from somewhere else, then there's no point in blocking Gramex. So you can handle that using asynchronous functions. And what I'll do is in this session show you how you can use a built-in set of asynchronous functions to fetch data from the web and display it without blocking the server. So at the core of it is Tornado's async HTTP client. You can create that using tornado.http client.async HTTP client, and then use that to fetch results. But the important thing about async HTTP client is that it doesn't return the results that this URL fetches. What it actually returns is a future, and you can yield that future. When you do this, so when you take a future and yield it, what happens is Gramex waits without blocking. And while this is fetching the results, it can fetch any other set of results and then give you the result. Then finally, you return the result. Now, this is an artifact of Python 2. You don't need to do this in Python 3 anymore. You can just say return result.body. So what this fetch body function does is takes a URL and returns the result without waiting for or without blocking any other fetches. The whole thing is wrapped in a tornado.gen.coroutine. Now, how can we use this? And more importantly, how can we test that it isn't really blocking? Well, let's do this. HTTP bin.org has a delay function. So if I said delay/3, then it will wait for 3 seconds. And then at the end of 3 seconds, it will print some details about the query that I sent. If I said delay/2, then it will wait for 2 seconds and then change and then print the results. So what I can do is create a function handler. What that will do is take values from the URL query parameter x. So if I said x is equal to 1 and x is equal to 2 and x is equal to 3, then it will fetch the body from delay 1, delay 2, delay 3. But here's the important thing. We want to do this in parallel, not in sequence. So while the first is fetching, the second should be fetched. While the second is fetching, the third should be fetched, and so on. So if the result is displayed not in, let's say, 6 seconds, 1 plus 2 plus 3, but rather in 3 seconds because it's running in parallel, it fetches the first and displays it immediately, fetches the second and displays it immediately, and so on, then we've proven that things are working fine. So how exactly does this code work? What we do is at first start by holding and initiating the requests and storing the futures. So we loop through all the args in args.x, which could be x is equal to 1, x is equal to 2, x is equal to 3, and then initiate fetch body and hold the futures. Now, after all the requests have been initiated, then we yield the futures. So for future in futures, then yield the first future, yield the second future, yield the third future. So what this means is that as soon as the first future is done, it will be returned. But in parallel, the second has been executing. And as soon as that's done, it will be returned. And as soon as the third is done, it will be returned, and so on. Let's try this out. So what we're going to do is copy this. We'll say async HTTP client is tornado.http client. We'll need to import that. We also need to import tornado.gen. And remember, we don't need to raise this return. We can just return this as a regular function. So now fetch body will fetch a URL asynchronously. Let's create the actual handler. This is called URLs, and it will take $x and return the results one after another. Let's map this URLs to a function handler. in the microservices section, we'll go to function handler and add a function handler called URLs, which is calculations.urls. And let's specify the content type as text/plain so that it won't appear as HTML. Text/plain and submit it. Right. So now we have URLs. Let's take a look at the output /URLs that requires an args.x. So right now it's printing nothing. But if I set question mark x is equal to 2, then after a 2-second delay, it should fetch the results from HTTP bin, and that says delay/2. Now let's see what happens if I set and x is equal to let's say 2 again. So it takes 2 seconds. It would have, well, okay, maybe I shouldn't have printed it here. Let's take a new window. Yeah, it's going to take 2 seconds, print, and then almost immediately it printed the second one. That's because while the first was running, the second was also running. What happens if I do x is equal to 2 and x is equal to 3? It takes 2 seconds and let's redo that. I'm going to refresh this. After 2 seconds, it prints, delay 2. And then 3 seconds later, it prints delay 5. Now, the reason it took only 3 seconds, not 5 seconds, is because it was running these in parallel. Let's verify that. If I said x is equal to 2 and x is equal to 1 and x is equal to 4, what I expect is all three will start. The 2 will be printed first, but the 1 would have completed by then. So immediately the first 2 would be printed, and then 2 seconds later 4 should be printed. Let's try that out. So 2 seconds later, I expect to see x is equal to 1 and 2. So yeah, both of those is printed, and then 2 seconds later we have delay 4 printed. So clearly that proves that these are running in parallel asynchronously. And more importantly, I can run multiple URLs. So let's say there's one user on the left-hand side who's waiting for x is equal to 10 and x is equal to 20 and x is equal to 30. Well, let's not wait for so long. Let's say 5 seconds and 10 seconds and 20 seconds. Now, while this user is being served, I can once again ask for a request here in parallel. And this request will be serviced while this request is being processed. So you'll notice that this request already came through. So let's open a new window. This request is has started. Let's start this request also in parallel. And let's open a new request. So while this request is still running, this request has processed. And while this request is being processed, this request is being processed. So you can have any number of users without adding too much to the CPU load because all of these are handled asynchronously. So that was a quick example of how you could use asynchronous functions. There's one thing that I'll just clarify. When displaying the URLs, earlier I had content type text/plain. It turns out that text/plain waits for the entire text to be downloaded. So instead I was using application/JSON, which is what allows the browser to display it in a streaming way. Text/plain in the browser makes the browser wait for the entire output. So with that caveat, what you can do is use asynchronous functions in Tornado Function Handler to fetch data from an API or even run queries. You could run a calculation on Spark, for example, on the database side in parallel and return the results as soon as they are done without blocking Gramex.